So today our topic is about higher order derivative and the product rule. So I will give the definition about product rule and higher derivative and offer some examples. And later Leaf will discuss about the homework. So our goal is to find the higher order derivatives of function and find an equation for acceleration from a position function and find the derivative of a function using the product rule. So with higher order derivative, oftentimes more than one derivative can be taken for a differentiable function. These derivatives imply continued continuity, like first derivative, and can be used to find helpful information about a function. The notation of higher order derivatives. So we can derivative a normal function and the result is a first order derivative. So when we derivative the first order derivative, we can get the second order derivative. So it means using this way we can get the n times derivative. Let's see some example. First, find the third derivative for this function. We can derivative the function, and the result is 3x squared. And take the derivative for 3x squared, we can get the result for 6x. And last, we can get the result for third derivative, and it's 6. So the answer is 6. Found the fourth derivative. So first we can find the second derivative is 20x cubed minus 3, and then we can find the third derivative is 60x squared, and the last we can get fourth derivative 120x. So the answer is 120x. The third example is find the fourth derivative for sin x. So we can get the result for first derivative is cosine x, and then we can get the result for second derivative it's negative sin x. Then we can get result for third derivative is negative cosine x. At last, we can find that the fourth derivative is sin x. So the answer should be sin x. So what is acceleration? Acceleration is a derivative of velocity and the second derivative of position. So let's see the fourth derivative, a fourth example. The position of a particle is given by the equation xt is equal to 4t cubed minus 3t squared plus 5t minus 1, and we need to find the acceleration. So we can derivative the position and get that and find that the velocity is 12 x squared 12t squared minus 6t plus 5, and we can derivative the vt, and then we can get at is equal to 24t minus 6, and when t is equal to 3, we can find the acceleration at t equal to 3 is 66. So the answer should be 66. the velocity of a particle is given in the table below, determining the acceleration of the particle when t is equal to 5. So as we can see, when time is equal to 4 seconds, the velocity is 10, and when time is equal to 6 seconds, the velocity is 9. And the acceleration is the slope of the velocity function. So we can put in V6 and V4 and use V6 minus V4 divided by 6 minus 4, and the result is 3. So the answer for acceleration is 3. Product rule. As a product of two differentiable function is differentiable itself. If f and g are differentiable, then their product fg is also differentiable. To find the derivative of a product, so the derivative of fx times gx is equal to derivative of fx times gx plus fx times derivative of gx. The derivative of a product is the derivative of the first function times the second plus the derivative of the second function. Example 6. Fx is equal to x squared times 2x minus 2. So the first derivative is x squared times 2 plus 2x minus 2 times 2x. And then we can simplify the function and get 2x squared plus 4x squared minus 4x. So this function is equal to 6x squared minus 4x. So the answer is 6x squared minus 4x. Example 7. Fx is equal to 3x cubed times sine x. So the derivative of this function is equal to 3x cubed times cosine x plus sine x times 9x squared. So we can simplify it, and we can get 3x cubed times cosine x plus 9x squared times sine x. So the answer is 3x cubed times cosine x plus 9x squared times sine x. Example 8. Fx is equal to x cubed minus 4 times 2 minus 3x. So the derivative for this function is x cubed minus 4 times negative 3 plus 2 minus 3x times 3x squared. And we can simplify this function and get negative 3 cubed plus 12 plus 6x squared minus 9x cubed. And it's equal to negative 12 x cubed plus 6x squared plus 12. So the answer is negative 12x cubed plus 6x squared plus 12. The product rule can generalized for any number of products. For example, the derivative for fx times gx times hx is equal to fx times gx times the derivative of hx plus fx times the derivative of gx times hx plus the derivative of fx times gx times hx. Example 9. The position of a particle is given by ft is equal to t squared minus 4t times cosine t, and we need to find the acceleration of the particle when t is equal to 2 over pi. So xt is equal to t squared minus 4t times cosine t. So vt is equal to t squared minus 4t times negative sine t plus cosine t times 2 plus 2t minus 4 times negative sine t. And the acceleration is equal to t squared minus 4t times negative cosine t plus negative sine t times 2t minus 4 plus cosine t times 2 plus 2t minus 4 times negative sine t. And when t is equal to pi over 2, then acceleration is equal to 0 plus negative 1 times 2 times pi over 2 minus 4 plus 0 times 2 times pi over 2 minus 4 times negative 1, and it's equal to negative 2 pi plus 8. So the answer is negative 2 pi plus 8.
So these are those homeworks. Question number 1. To find the derivative of g of x, we first apply the chain rule. Then after simplifying this function, we can get the answer. Number 3. To find the derivative of h of t, we first convert the square root form into the power form, and then apply the chain rule. After expanding the function and simplifying it, we can get the answer. To find the derivative of f of x, still the chain rule need to be applied, and the answer would just be negative x to the square of 3 times sine x plus 3x squared times cosine x. Number 62. We could apply the chain rule here. And the question asks for the value at point pi over 4. So just substitute the x into the function, and then we can get the answer of 1. So the answer is 1. Find the tangent line at that coordination. So we first apply the chain rule, then substitute x by 1 into that function. We can get the slope of the line, which is negative 3. And then we can get the tangent line. Since p of x equals f of x times g of x, we first apply the chain rule if we want to find the derivative of p of x. The derivative of g of x and f prime of x at x equals 1 can just be directly calculated from that graph, which is the slope at that point. And after substituting all values in the function, we can get the answer, which is 1. Same method here, so the final answer will just be 4. To find the derivative of f of x, just apply the basic rule here, and we can get the answer of f the second derivative of f of x. So the answer will just be 3 over square root of x. We first apply the chain rule. Then to find the second derivative, we need to apply the chain rule again. So the answer will just be negative x times sine x plus 2 cosine x. As we know, the velocity is 36 minus t squared. So the acceleration will just be the derivative of velocity, which is negative 2 times t. Substitute the value t by 3. We can get the acceleration and the velocity value. And since there are different signs, so the speed of the object is slowing down. Well, we can just set in a simple example for this statement. We set f of x equals x to the power of 4, so we need to calculate the fifth derivative of f of x. Applying the simplest rule, we can get 0, so this is true. And this is also true since the first derivative is the rate of change at that point. So the second derivative will just be the rate of change of the first derivative. As we know, the derivative of a constant is 0, and since acceleration is the derivative of velocity, so this statement is also true. Thank you.